0.700 grams of a monoprotic acid HX are dissolved in water. This acid solution is titrated with 30.1 ml of 0.110 mole per liter KOH. Calculate the molar mass of the acid. To answer this question, you need to write first a balanced reaction between HX and KOH. HX is an acid and KOH is a strong base, so this is an acid-base reaction. And the products are salt, KX, and water, H2O. If you check this reaction, this is already balanced. So we can proceed to the solution. The first step you need to do is to solve for the moles of HX. So how do we do that? If you read the problem, we are given the volume of KOH, which is 30.1 ml. What you need to do is to convert this first to liters. So we know that 1 liter is equivalent to 1,000 ml. So ml cancels out. Now we have liters. And in the problem, we are given the molarity of the KOH solution, which is 0.110 moles per liter. That means that for every 1 liter of the solution, it contains 0.110 moles of KOH. So liters will cancel. Now we have moles of KOH. And then you look at the balanced chemical reaction above. It says here that for every 1 KOH, it reacts with 1 HX. So you put that into your conversion. For every 1 mole of KOH, it reacts with 1 mole of HX. So moles of KOH will cancel, and now you can solve for the moles of HX. And this is equal to 0.003311 moles of HX. Now that you have the moles of HX, you can now solve for the molar mass of HX. So we know that the formula for molar mass is mass divided by moles. In the problem, we are given the mass of HX, which is 0.700 grams. So that is 0.700 grams divided by the moles of HX, which we just solved earlier, 0.003311 moles. And this is equal to 211, and the unit would be grams per mole or grams over moles. And this is the answer to the question.